Hello again, welcome to another lesson in geometry. Today we are covering section 9-3 rotations, and this is our last isometry. So this is the last transformation that will not change the size of the shape. So this will make congruent images in pre-image. All right, so review here. The diagram on the right shows the reflection of point A across the line of reflection. Draw the line of reflection that would make that happen. So we know that this occurred. Okay, and that line right there, that segment should be perpendicular to the line of reflection. So my line of reflection is going to be parallel to the y-axis here, and it should be equidistant away. So we're going to make our line of reflection be this red line, and then we can see that this forms perpendicular bisector. Okay, between A and A prime. All right, circle the equation of the line of reflection in the diagram above. So what is the equation of that red line? So that red line is x equal to 1. And if you're unsure, remember you can always make, actually that's x equal to 2 because our units are going by 2's. You can always make a table of our points. So we could have 2, 0, 2, 2, 2, negative 2, and you can see that x is always 2. So our equation is going to be x equal to 2. Be careful and read the scale. Okay, that way you don't pick one of these guys like I almost did. All right, vocabulary builder, rotation. A rotation is spinning a motion that turns the figure around a particular point. Okay, so the center of rotation and the axis of rotation are some related words. The center of rotation is the point we're going to spin it around, and the axis of rotation is like that thing we're spinning. Okay. All right, so a rotation about a point is a transformation that turns a figure clockwise or counterclockwise a given number of degrees. And this is a little bit weird. We'll talk about it later. Clockwise is actually a negative number of degrees, and counterclockwise is a positive number of degrees. Okay, so if you're going in the direction the clock hands turn, that's a negative rotation. And if you're going the opposite direction, that's a positive rotation. All right, use your vocabulary. Complete each statement with always, sometimes, or never. The rotation of the moon about the Earth never takes a year. Okay, used about a month or so. That's why the moon cycles through. A rotation image has the same orientation as the pre-image. This is always. Okay, it's not going to flip the shape over, so it's still going to be in the same orientation. So if it was triangle ABC, the new one would be triangle A prime, B prime, C prime in that exact order. Okay, the transformation is a rotation. A transformation is sometimes a rotation. It could be a reflection, it could be a translation, and it could be a dilation. Okay. A rotation is always a transformation, though. So the other way around always works. 110 degrees counterclockwise rotation is the same as 250 degree clockwise rotation. And this is true. So this is always true. Okay, so here's a point of rotation, center of rotation. Here's a point. If we rotated 110 counterclockwise, that's going to be not quite that far. Somewhere about right here. Okay. All right, but if we go in the opposite direction, 250, it'll bring it right around the same way. And that's because this 110 plus this 250 makes a total of 360, which is one time around the circle. Okay, so together, they're going to end in the same spot. All right, let's flip it over and see what's on our second page. All right, on the top of page 2, we have a key concept here, rotation about a point. So a rotation of x degrees about a point R, called the center of rotation, is a transformation with these two properties. The image of R itself, that is R prime, is the same as R. Okay, so if you rotate about a point and that place thing you're rotating is that point, it doesn't change. Okay, all right, so think of it as the hands on a clock. The hands of the clock rotate around the center of the clock, and that place at the center keeps in the same spot on the hand no matter what. All right, but for any other point V, R V prime, so the distance from R to the new V, is the same as the distance from R to the old V. And the measure of V, R, V prime, so the angle formed from the old V with the rotation to the new V, is going to be X degrees, where X is the amount we rotated it. So the positive number of degrees a figure rotates is the angle of rotation, and a rotation about that point is called as an isometry because it doesn't change the shape, just spins it around so the two shapes are still congruent, the image and the pre-image. So use the diagram above for exercises 8 through 10. The pre-image of triangle is triangle, let's see, VWU or UVW or any order you want, okay? And then the image is triangle, and then we have to keep them in the same because we're not changing it. So if U came first, U prime has to come first here, and then V prime, and then W prime, okay? So these shapes are going to be congruent, and their orientation is not changed. All right, RW prime is going to have the same distance as RW. So RW prime, that's to right here, will be the same distance as RW prime, okay? And the angle measure of WRW prime, this is still going to be X degrees, okay? The same as it was before. All right. And then we have RU. That's going to be the same distance as, this is RU prime as RU. And the angle is still going to be the same, X degrees. All right. Problem number 1, drawing a rotation image. So what is the image of triangle LOB if it's rotated 50 degrees, that's positive, about point B? So describe the image of B. Let's see, so this would say something like B, and its new image, B prime, are in the same location. So it doesn't move the center, remember? We're rotating around B, therefore B prime is still going to be right on top of where B was. All right, so follow the steps below to draw a rotation image. So we know that B and B prime are going to be the same, so we're not going to move B, so we're going to move O and L. All right, so use a protractor to find the degree, 50 degree counterclockwise angle from vertex B inside BO. So we're going to line up our protractor, so the center is at the center of rotation, and I'm going to put one side of it on O, and then I'm going to measure out 50 degrees, which is right here, okay? And then I'm going to grab my ruler or any other straight edge. It doesn't have to be a measuring edge. And I'm going to draw in that angle of rotation. All right. So here we go. Now I know that this angle formed is 50 degrees. Okay. All right, now I need that the distance from B to O need to be the same as B to O prime. And here we can use our compass to measure distance. We don't need a ruler here. So I put the pointy end on B and the writing end on O. And then I'll rotate it around and we'll make a mark. Okay, so where this crossed, this is now going to be O prime. Now my distance is the same and the angle of rotation is 50 degrees, just like it's supposed to be. All right, so we're going to do the same thing with L, because we've already built BO prime, just like we were supposed to, so that they're congruent in length to BO. And now we're going to do it with L. So the same kind of thing. We'll put the center of our protractor on B, and we'll rotate this around so it lines up with L. And then we're going to measure out a 50-degree angle, and I'm going to do it in red again here. So here's my 50 degrees. Okay. I'll get my protractor out of the compass, or protractor out of the way. I'll use my straight edge here. And here we have B, L prime. Okay, it's going to be somewhere on this line. All right, and that's because this distance is also 50 degrees. All right. So we're going to take our compass and we're going to measure from B to O. So let's rotate it around, or from B to L. I'll shrink it down a little. Oops. All right, so pointy end's on B, the writing end is on L. Now we know the length. Okay, so we'll rotate it around here, and then we'll draw in where L prime's going to be. So now we're done with this guy, and here is L prime. All right, so at this point we can connect them and make our triangle. So it looks something like this. So let's do it in black. So there's O prime to L prime, and then O prime to B prime. So B prime and B are at the same spot, and B prime to L prime. All right. So we have rotated our triangle exactly 50 degrees about point B. So draw in triangle LOB, which I've done. All right, let's flip it over and see the next page. So it says the center of a regular polygon is a point that is equidistant from its vertices. So the center and the vertices of a regular n-gon determine the incongruent triangles that form to make it. Okay, so the center of the vertices of a square determine 4 congruent triangles to make it. So we have a regular polygon, so a regular quadrilateral is a square. Okay, and the center we could find on a square really easy. It's just find the diagonals. The center is here, and notice it creates 4 congruent triangles. So each one of these triangles in here, 1, 2, 3, 4, are the same, okay? And together they make the square. So if we extended how many sides there were, then we do the same thing. The triangles just look a little bit different, but they're all congruent to each other, okay? All right, so problem number 2, identifying a rotation image. So point X is the center of the regular pentagon PENTA. So X is my middle here of this regular pentagon. So we know that all the triangles formed, there should be 5 of them, and all of them are congruent. So PXE is going to be congruent to EXN and so forth. So the center and the vertices divide penta into 5 congruent triangles. If it had 5 sides, the center divides it into 5 congruent triangles. So if you divide 360 by 5, you can find the measure of a central angle. And a central angle is one of these guys right here. So in this case, 360 divided by 5 would be its measure. So each central angle here would measure 72, because if you divide 360 by 5, you get 72 degrees. All right, underline the correct word to complete each sentence. 144 rotation is 2 times the rotation of the measure in exercise 16. Okay, so 72 times 2 makes 144. So 144 degree rotation moves each vertex counterclockwise 2 vertices over. Okay, so if we rotate around the center 140, E is going to move to A. Okay, 144. So circle the image of E for 144 degree rotation about X. So E would turn into A. All right, big problem number 3, finding the angle of rotation. So we have some hubcaps here. Hubcap of a car wheels often have interesting designs and involve rotations. What is the angle of rotation about C that maps M to Q? So here's C at the middle of the hubcap, and we want to take Q and send it over here to M, okay? All right, so the hubcap design has, well, let's count them, how many spokes? 1, 2, 3, 4, 5, 6, 7, 8, 9 spokes, okay? And that spokes divide the circle into 9 congruent parts, okay? Each angle at the center of the measure is 360 degrees divided by 9, which should make 40 degrees. So all of our central angles are going to be 40. So that angle in there should be 40 degrees. All right. So as M rotates counterclockwise around from C to Q, M rotates through, what's C here? 6 spokes. Okay, each of them 40 degrees to end up for a total of 240 degrees. So the angle of rotation about C that maps M to Q. So I want M to get mapped to Q, so I have to start at M, and I want to map it all the way around, rotating it till it gets to Q. It's going to be 1, 2, 3, 4, 5, 6 of those. That's where this 6 came from. Each one of them is 40 big, so this is going to be 240 degrees again. All right, let's flip it over, look at the last page. Okay, on the top of page 4, we have one more big problem here. Problem number 4, finding a composition of rotations. So what are the coordinates of the image of point A at -2, 3 for a composition of two 90-degree rotations about the origin? All right, so here's the thing about rotating twice. It's the same as just adding them together and doing one rotation. So the composition of two 90-degree rotations is the same as a 90-degree rotation plus another 90-degree rotation for a total of 180-degree rotation. All right, so we're just going to do 180. Why do two of them? All right, so complete each step to locate point A on the diagram at the right. First, we're going to draw in AO. Okay, so I'm going to put in AO here. And I'm going to go on past it, and I'll show you why in a second. So use a protractor to draw a 180-degree angle with the vertex O and the side of OA. So we would measure out a 180-degree angle, say from here. Okay, so there's our starting place. We want to do 180. I don't really need a protractor to do that. I'm pretty sure you know that 180 degrees is going to make a straight line. So I'm just going to do my 180 and show that it goes on around to there. Okay, so there's my 180. And now I just need to figure out how long is it from O to A prime. And this is where we would use a compass to measure our distance. So we put the pointy in on the center of rotation. Okay, and then the drawing in on A, the thing we want to rotate, and we'll spin it around. Oops, let's lock that back in place here. Okay, so we spin it around. I'm going to just do a flip here, and then I'll mark in that. Okay, so this piece right here is the same distance away from O as A is, so this is A prime. Okay, so notice we can find the coordinates of A prime. It looks like it's exactly 2 to the right and 3 down. Okay, and for 180-degree rotation, this is nice. Look at this. So all we have to do is flip the signs to change the opposite on each of the coordinates. So the x-coordinate changed from -2 to its opposite of +2, and the y-coordinate changed from 3 to the opposite of -3. And this will happen whenever we rotate about the origin, not for when we rotate around some other point. Okay. All right, so now we have a lesson check, and as always, pause the video, do the lesson check yourself, and then come back and check it over. Okay, welcome back. Hopefully you did these to yourself to practice a rotation by yourself one time. Compare a rotating figure about a point to reflect the figure across a line. How are the transformations alike and how are they different? So we're going to rotate this one first, and I'm going to do it down here and then move my points back up because I need a little bigger for the smartboard. All right, so here it is. We're going to rotate RST 90 degrees about the origin. So I'm going to start with doing the rotation of point R. So I'll draw in a straight line from the origin through R. And then I need to measure 90 degrees. So we'll grab a protractor and measure out our 90 degrees. We got to slide this down. Okay. All right, so here's our protractor. We're going to go in here and spin it around till we get 90 degrees. All right, so there it is lined up, and 90 degrees is going to be right here. Okay, and then we're going to draw in our line. Okay, so we're rotating 90 degrees. It's going to look something like this. All right, then we're going to take our compass to measure out the distance. So here's our distance from O to R, and if we spin our compass around, we can mark in the R prime. Okay, and R prime is going to be right here. Notice it went from 1, 1 to -1, 1. All right, let's do the same thing with each of the other points. So first we need to draw in from O to T, the straight line. All right, so I'm going to line it up. Here's our O to T. Okay, I'm going to do this one in blue. Okay, then I got to measure 90 degrees again. So we put the center of the protractor on the center of rotation, spin it around, find our 90 degrees, and mark this off. So there's our 90 degrees. And then we take a straight edge and draw in from O through that place where we marked. Okay, a 90-degree mark. Okay, and then one more time, we have to measure the length here. So let's spin this around. We'll measure out from O all the way to T. Oops. And somewhere about right there. So if I spin this around, it looks like it's on T, and then I'll come up here and mark it in. Okay, so this is going to be T prime right here. And then we have to do it all that one more time to move S. Okay, so we get our straight edge. Okay, line it up with the center of rotation and S, and I'll do this one in green. All right, so we're done with our straight edge. We can get that out of the way. We take our protractor for the last time and measure out our 90-degree angle. All right, so 90 degrees is going to be right here. Okay, and then, oh, we do need that straight edge one more time to draw in that part. Let's get this out of the way. All right, so there's our 90 degrees. And lastly, we'll take our compass to measure out our distance correctly. So once again, the pointy in on the center of rotation, and we're going to spin this around so we can get it on drawing in on S, which is right about there, I think. That looks good. We come over here to the green one, and we draw this in. All right, so there is S prime. Okay. All right, so if we draw in our new triangle, it's supposed to go from, let's do it in black, S prime to R prime right here, and then up to T prime and back over here. Okay. All right, so let's transfer these coordinates. So we already said R prime was at -1, 1. So let's go back up here and put it here. There's R prime. And then let's take a look and see where S prime went to. S prime went to -4, +2. So we'll go back up here and put S prime at -4, +2. And then we'll see where T prime went to. T prime went to -2, +4. -2, +4 is right here. And there is our triangle. Rotate it 90 degrees about the origin. All right, so if we take a look at it, you can see some things happened. R went from 1, 1 to 1, -1. T went from 4, 2 to -2, +4. And S went from 2, 4 to -4, +2. So it did some stuff with the same numbers, and we can figure out some patterns in this in class next time. All right, so number 29, reflect RST across the y-axis. This is a much easier job to do. So R prime will be right here, one distance away from the line of reflection, just like R was. S prime will be right here. This was a distance of 2 from the line of reflection to S. So S prime will be here. And T prime will be, let's see, 1, 2, 3, 4 away. So 1, 2, 3, 4. And we get this. Notice the triangles end up with the vertices on the same coordinates. However, the coordinates don't match. For instance, there is a point at -2, 4 in both, but in one place it's called S prime and the other place it's called T prime. Okay, so circle the transformations that preserve the size and shape of the preimage. It should be both. Okay. Remember, this is an isometry, so it's always going to make congruent shapes. And then we want to underline the one that preserves the orientation. Okay, so the orientation is supposed to be the same. So like here it goes RST, and over here it goes RST. Okay, so for our rotation, so this way was RST going this direction, and here it's R prime S prime T going in the opposite direction. So one of them, the orientation was clockwise and then changed to counterclockwise. But for our rotation, RST still clockwise, and R prime S T prime T prime still clockwise. So for our rotation, our orientation stayed the same. Okay, but for our reflection, it did not. And that's because when you flip it upside down, it reverses the orientation. So how are reflections and rotations alike, and how are they different? All right, so how are they alike is going to be the size and shape, okay, stay the same. That's the alike. Okay, we're always going to end up with congruent, okay, figures. How are they different? Reflection reserves the orientation. Okay, so a reflection does not reserve the orientation. So when you reflection, you're flipping it over, and the orientation or the order in which the vertices come as you go clockwise or counterclockwise around the shape changes. Okay? All right, so that concludes our notes for today. So hopefully you understand what rotation means, spinning around a center of rotation. You certainly don't know one of these without the other again. The angle of rotation is how much are we going to spin it. So you probably know that one also if you know the first two. And then this one's a little bit different, the center of a regular polygon. We learned that as a special problem in a couple of the examples. Okay, I think they're on page 3. So hopefully you're in this range. If not, you want to watch the video and then maybe come for some help before our next class. I'll see you then.